and swap, and swap, and swap with itself. Welcome back to Arcade. I am Super Tommy, and this is going to be a video on the Fisher-Yates shuffle in JavaScript. So this is an algorithm, and it's an algorithm that lets you shuffle an array in a time-efficient manner. So I've been seeing on Twitter people talking about whether you can get a computer programming job without a CS degree. And of course, I personally do not have a computer science degree. I have a marketing degree. So I have yeah, that's my degree. Although I was programming since I was about 13, and I've been working in the games industry for 13 or so years now, a little bit more than that probably. So, and one of the best courses I took on algorithms was from Coursera, the Stanford Data Structures and Algorithms course. I don't remember if this algorithm was there or not, but it is one of my favorite shuffle algorithms to do. But for sure, in the games industry especially, you don't really need a CS degree to get a job. Really what you need is the ability to actually make games and write good code. Now you can learn a lot of this on your own on channels like this one, Arcade's YouTube channel, and from courses you find elsewhere. So now let's look at implementing a Fisher-Yates shuffle in JavaScript. So we have a scene, or we have code set up here, and there's some methods that we're not using, or functions that we're not using right now. What we're going to do is implement a shuffle in this callback on the click. Now, just to show you what our little demo looks like right now, you've got these 10 tiles that corresponds to this array of 10 items, numbers 1 through 10, and we're going to shuffle them, and you'll see the numbers basically switch positions when they get shuffled. So this uses Pencil.js, which is a open source library you can find on GitHub that is pencil-js. So github.com/pencil-js. And it's a canvas drawing library, which is simple to use. So that's why we're using this one instead of something like Phaser. We don't need a complicated game engine to do this, just to visualize how this shuffle is going to work. So the Fisher-Yates shuffle, if you go to Wikipedia like we have here, you'll find an explanation of how it works, but you'll get to know how it works by doing it in the code. And so this is their pseudocode right here. We're going to be basing it on the second pseudocode that they have, where we're going to go from I being 0 to the length of the array minus 2. So in our case, we're going to go from 0 to 8. We're going to count from 0 to 8. Then we're going to generate a random number where the random number is going to be greater than or equal to the value of I currently and less than the total length of the array. And then we're going to swap them. So let's just get started and we'll show you how you can do it. Now, some of the pseudocode may be confusing, so hopefully it helps you to see it written in actual code from pseudocode. Now, I always forget how to implement this algorithm, since I don't do it that often, as ideally you would use a method from a library that's been well tested, because even if even while we copy it from pseudocode, can still make errors. So libraries that have been battle tested, that is open source, have been used by many people, are more likely to be correct than your own implementation. And there are many ways to subtly mess up this implementation. So let's start. We make some errors. Let's see. All right, first let's make a for loop for I. So we're going to start at 0. So because we're going for I from 0 to n minus 2, which means I 0, and then we're going to go through this array as long as I is less than the size of the array. So our array is list. Right here, so we're going to make a new variable called size, list.length. That'll give us the total length, or the total size of the array, size minus 2. And then we're going to increment I as normal in a for loop. So before we continue, this tiles here, this create tiles function that we have, it's something that we've pre-made. just to make this code easier to read. But what it does is basically lay out this tile grid that you see. All right, so back to our Fisher-Yates algorithm. So the next thing we do is we want to generate a random number. So we're going to call this J, since it is J here, but you can call it R. I do like to use R sometimes, but these single letter variables are not always the best. Some would say they're always bad, but for simplicity here and to match the pseudocode, we're going to use J. So we want a random integer that is greater than or equals to I, whatever I is currently, so it starts at 0, and less than but not including 2, so not equal to size. So in our case, size is 10. So it's going to be from whatever I is in the first iteration through the for loop, it'll be 0. So any number between 0 and 9. So that's how we got to generate the random number. So let's look at JavaScript's math.random method. You've probably used it before if you've done JavaScript programming. So math.random returns you a random number between 0 and 1, not including 1. So what we want is integers. We don't really want floats or numbers or like decimals, right? We want from 0 through 9. And so we would have to multiply math.random times some total amount to get it from 0 to the total amount. But in our situation, we need it in between a min and a max. Since I is not always going to be 0, I will be 1 on the second iteration and 2 on the third iteration, and so forth. So W3 Schools here has an example of what they call a proper random function. But effectively what it does is it gives you lets you provide a range, a min-max range, and then returns you a number that is from min to max, not including max. So if you just read it right here, this JavaScript function always returns a random number between min included and max excluded, which is exactly what we want. As you can see here by this pseudocode, I less than or equals j less than n. So j is going to be greater than or equals to I and less than n. And so let's go back here. We want this. So we're not gonna copy this. You could copy this straight up if you wanted to, but we're gonna write it out. And so we will do math.random, right? So the first thing here is we're gonna do random. So max minus multiply. So max minus min. So in our case, max minus min is max of size, min of I, right? That's our max and min. And then we're going to floor it, math.floor, so that it is rounded to the nearest integer, rounded down. So if it's like 0.3, it's 0. If it's 1.5, it's 1. If it's 1.8, it's also 1. Okay, and then lastly here, we're going to add min. In our case, min is I. Okay, so this is our random number that's going to generate between I and size, I included, size excluded. Back to the pseudo code. Now we have a random. Now we need to do a swap between the position of the item at I, or rather, we're going to swap the item at position I and the item at position J, our random number. So let's just set them up real here. So we're going to call current as in the current item at position I. As we iterate through the for loop, the current item is whatever the item is at I. So 0, 1, 2, 3. So list I. So that's our current item. Now we'll call this our random item, which is going to be list J. So now we have these two. Now we need to swap them, or in this, it says exchange, swap. So here's how we're going to do a swap. Now we have both saved. So now we need to set the position, the item at the position of J. So that's the random position. So here's the list J. So this is the position at the random location that we generated, or that we created here on line 26 here, const J gets the random number, should now be the current, whatever the current is, which is the value of the item at position I. And then we're going to replace what was at the current item with the random item. So if you look here, current corresponds to I and random corresponds to J. To do a swap, we say J corresponds to current. So like it's a almost like a cross multiplication, right? We're swapping it. And then I corresponds to random, where previously I corresponded to current and J corresponded to random. Okay, so there is that. Now what we need to do is actually draw the list into these tiles. So we have this update tiles method right here. So that's what that'll help us do. So this is the entire shuffle implementation. You won't see it, but it does work. So we'll actually show it to you. Let's see, we're gonna do, delete this to do, we're gonna do a log. So console.log list.join that. And then once we have it shuffled, we're gonna do another log of the list. All right, so we hit shuffle. This is the original list you see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this is the shuffled list, right? So now they're not in order anymore. They have been shuffled. So what we're going to do to make this more interesting is we're going to show you how it does it effectively, one step at a time. For each 2 pairs that it swaps, we're going to visualize so you can see it in action and see that this algorithm is in fact working. So first here, we are going to do, let's set the colors. So we have this tiles array, which is a parallel array to this list. When we create the tiles, effectively we have 1 tile at every position here from 0 to 9, just like our list with the numbers 1 to 10 in the indices 0 to 9. So that means if we do tiles I, for example, that's where we're at, we can change the fill color. So this is part of pencil.js. It's not really important for you to know because this set options is a part of the pencil.js API. And so now let's just do this for the current tile and the random tile. So we're going to set them to red. And then what we're going to do is wait 1 second. We're going to wait 1 second. It's going to be highlighted red. Then we're going to do update tile. So this will update the tile. So let's say we're going to update the current tile. This is just the visuals. The current tile with the value currently in the I index, which we've already swapped, right? So we already did the swap here. And then we're going to update the tile at index j with the value at index j in list. So now that means we've updated the tile, so the swap has happened visually. It happens here in code, then it happens here visually. So now let's just set the color. Let's do it up here right before it's going to do it. And let's make it blue. So this is RGB, so blue is the last 2 digits over here. Now we do the swap visually. Let's wait another second so that we see it happen, and we are going to change this back to black. So now in pencil.js, you could use, if you're using render, you need to call render to actually draw the changes you've made. Now pencil.js has a start loop, which will draw it every request animation frame loop. That would be more like a game engine that you're familiar with, where it has its own update loop and its own render loop. But we don't actually need to be rendering 60 frames a second. Doesn't matter to us. There's really nothing going on here. So we're going to manually call render when we need to draw something. So after we change the color we want to draw or render, then we change the color and update the tiles, and we want to render. And then when we update the tile background back to black, we want to render. Okay, Let's save. Now let's do a shuffle. Oh, we got an error. Tile is, oh, yes. Okay, so this error is not tiles, tiles. Tiles, tiles, tiles. Right, so right here, our array of tiles is called tiles. Let's try that again. Boom. Oh, oh, missed the tile somewhere. Tiles, tiles, tile. All right. Swapped and swap and swap and swap with itself and swap and swap. Swap with itself, swap with itself, and there we go. And so now here's the array. As you see, this should match up here. And so that's the Fisher-Yates shuffle. We can see it again. We can reshuffle this. As you'll see, this will just play out. And so that is the Fisher-Yates shuffle algorithm. So we used Pencil.js and just normal JavaScript. There are no classes here or anything like that. We are using ES6 modern JavaScript. You see these imports. But the crux of the shuffle implementation is getting the size of the list or the array, creating a for loop that goes from 0 to the size of the array minus 2, generating a random number from between I and size, inclusive of I, exclusive of size, and then swapping the values at I and the random number that you just generated. So just to finish up here, there is another way of doing the Fisher-Yates. We're not going to implement it here. It is going from the back of the array to the front. Now you can implement it this way. I do find this version going from I0 to a number to be easier to reason about than going backwards in the array. But do give it a try if you'd like. It is slightly different, and you can see here where we're going to get a random number that's between 0 inclusive and I inclusive, and then we exchange those items at those values. So give it a try, and that was it for this Fisher-Yates algorithm in JavaScript.